Welcome to this episode of this series of medical statistics. Suppose I told you OCT for the diagnosis of glaucoma has a sensitivity of 90% and a specificity of 90%. Question: an OCT printout with positive changes of glaucoma means that we are 90% sure that the person is glaucomatous. Is this true or false? Actually, this is not true. The goal of this video is to explain why it is not true. Different studies showed the values of different parameters of OCT for the diagnosis of glaucoma with different sensitivities and specificities. Suppose I told you that the retinal nerve fiber layer in OCT has a sensitivity of 90 and a specificity of 90. This means that the red group, these are the group with glaucoma, the green group are the group of normal persons. So 90% of the group of glaucoma will show real positive results, and 90% of the normal will show real negative results. So sensitivity is the proportion of subjects with the disease in whom the test result is positive, while specificity is the proportion of subjects without the disease in whom the test result is negative. Now, if we apply 90% sensitivity, this means we are going to have a real positive results in 90% of the group of glaucoma. The remaining will show us a negative results, a false negative results. On the other hand, specificity 90% means that 90% of the normal persons will appear normal, no results of glaucoma, but 10% will show abnormal results, false positive results. So this is sensitivity 90%, remaining false. This is specificity 90%, remaining false positive. So patient with positive results in OCT, if we have such a finding, this does not mean that 90% we are sure he is glaucomatous and only 10% he may be normal. This concept is not real. The prevalence tells us how much the disease is present in the community. Don't mix that with the term incidence. Incidence means the new cases per year. In this presentation, we are interested in the prevalence. Suppose we have a community of 2,000 persons, and I told you that the prevalence of glaucoma is 50%. So half of the group, they get glaucoma, the other half, they are normal. If we apply this table, they get the test and we have these percentages. So we are going to really include glaucoma, diagnosed glaucoma in 900s and miss in 100. And in the normal, we are going to exclude the disease in this number, but falsely, we are going to include positive results in this number. This is the real incidence of glaucoma, 2%. So 2% of this number of community, only 40 persons they get glaucoma, the rest are normal. So again, if you apply the table on these numbers, we're going to have a real positive results in 36 out of the 40, but we're going to have a false results, positive results in 10% of this group. So going to have a total positive results of glaucoma in 232 persons. 36 of them are real glaucoma and the remaining are normal persons. So 15% of the positive results here are real glaucoma and 85% are normal persons wrongly diagnosed to have glaucoma. And the first assumption, because the prevalence is high, then we get diagnosis correct in 90% and the false diagnosis was only in 10%. So the prevalence is known as the pretest probability of occurrence of the disease before doing the test, and here we have the post-test probability. So pre-test probability was 2%, but after making these calculations the probability increased to 15%. So the test results does not depend on sensitivity and specificity, but also on the prevalence of the condition. So keep in mind, pre-test and post-test probability, they take in account the false positive, false negative rates, and also the disease prevalence in the community. As you all know, diagnosis of glaucoma depends on so many factors. I'm going to concentrate, say, on 3 factors. Suppose I told you cupping helped diagnosing in glaucoma with a post-test probability 15%, ganglion cell thickness in the macula and the OCT will help diagnosis in 15% post-test probability, and field nasal step they get has a post-test probability of 15%. So any single test of them, they have a test probability of 15%. Suppose we have a patient who is positive for the 3. So we can add them together and we are sure that the post-test probability increases to 45%. So this concept of pre-test and post-test probability is applied to all signs and symptoms and investigations in medicine. When we have multiple post-result signs or investigations, the post-test probability equals the addition of the probability of each. This will increase the likelihood of having a proper diagnosis. To sum up, sensitivity and specificity are not enough. We have to consider prevalence, or what is known as the pretest probability, to reach to the post-test probability. Second, adding multiple post-test probabilities increases our confidence in the diagnosis. Thank you for your